In a surprising discovery, Professor Monika Österberg's team at Aalto University was able to make brown lignin iridescent and transparent, completely by accident.
The goal was to make a more hydrophobic lignin so that I could make, for example, hydrophobic surface coatings.
In one of Alexander's experiments, things didn't go as planned, and the lignin dispersion turned out to be transparent.
And I thought that, okay, this is not at all what I had expected, but I have to do something with this. This is so special in some way.
Having discovered a transparent form of lignin, Alexander began searching for useful applications.
And I had read about anti-fog coatings before and how particles can be a very effective way of achieving super hydrophilic properties for anti-fog applications. And it turned out that these lignin particles worked like that as well.
When the coating is applied, for example, on the lens of diving goggles, it creates a hydrophilic layer that inhibits the formation of water droplets, or fog, on the lenses. But there are also substantial industrial needs for anti-fogging coatings.
For example, in agriculture, in these greenhouses, it's important that the sunlight comes through effectively. So fog is actually reducing crop yields also in these greenhouses.
The invisible lignin has already inspired the commercialization of an anti-fog lignin product for the consumer market by the company Boreal Bioproducts. But this was not the end of surprising discoveries.
I was preparing a sample for electron microscopy. And in the beginning, it was very simple. I just kind of added a droplet of the lignin particle dispersions. When it had dried, came back and saw that there were these kind of waves of different colors going kind of around the center of where the droplet had been.
We realized that when we have a thicker layer of the coating, some faint colors started appearing. And we were curious that this was not the color of the lignin, which should be brown. This was some more vibrant and colorful rainbow colors.
And Sahar, she was doing layer by layer deposition. And so I thought that maybe she would be able to figure a way to control the thickness.
What we achieved was, based on the thickness of our coating, we could get different colors, shade, such as blue, yellow, and purple. And just like nature, when we were looking at our coating from different angles, we were seeing different shades of color, exactly like butterfly wings.
But these colors look much brighter than paint, at least in some cases. So there are now some car models, for example, that have photonic coatings instead of just pigments.
For instance, it can be used for smart sensors that they want to be responsive to the environmental changes. It can be used for color-changing coating that they normally use for banknotes for security reasons.